Assalamu alaikum wa rahmatullah. I hope you are having a good day. So this is me again, Muhammad Hayyan Sibai from Faculty of Engineering Technology. I am continuing part 2 from module 2 from our course Microcontrolling Start as Professional. So in this part we will continue speaking about number system. We will speak about actually the relation among number system. We will speak about the decimal binary conversion, how to convert between binary and decimal. Also by the end of this video you will be able to understand what is ones and twos complement and how to use them to represent the signed numbers, how to represent the signed number in computers. Basically last time we speak about the binary numbers. So the binary number system is used to represent values in computer because, as we said, computer is representing value using 0 and positive voltage. This positive voltage actually is a 5 volt usually. So binary has a radix of 2 and uses the digits 0 and 1. 0 represented in computers in 0 volt and 1 is represented with positive volt, which, as we said, it is a 5 volt. Now the column, when we see the numbers, as you see the numbers here, so the column actually, its column has a weight, and this weight starts from 0, 1, 2, 3, 4 and so on. From right to left, beginning with the 2 power 0, which is equal to 1. So these are the basic numbers. I recommend you to get familiar with them because usually we will use the numbers between 0 to 15. Here 0, 0, 0, here 0, 0, 0, 1, 0, 0, 1, 0, 0, 0. Each number actually is increasing one number from the previous one. For the fractional values, as you see, we continue the same concept. So instead of adding one weight for each column, we add minus 1. So minus 1, minus 2, minus 3, minus 4, and so on. So a number like this, actually, we can also represent a fractional number using this concept. So a number written in binary as 101.01, it's like to convert it to decimal number, we just use the column or weight or the weight or the position weight. So as you see here, this one is actually this one. So 1 multiplied by 2 power 0, 0 multiplied by 2 power 1, and 1 multiplied by 2 power 2. So this is the integer number. For the fraction, so we have 0 multiplied by 2 power minus 1, 1 multiplied by 2 power minus 2. So as a result, we will have 4 plus 0 plus 1 plus 0 plus 0.25. These are in decimal, of course. And then the result is 5.25 in decimal. Now this is very simple how to convert from binary to decimal. Okay. Now to convert the opposite direction from decimal to binary, so you can convert decimal to binary using division actually. So you can divide by the radix. So now if we want to convert from decimal to binary, we divide by 2. So this operation is shown here. So as you see here, we want to convert actually the number 49 in decimal. We want to convert the number 49 in decimal to its equivalent in binary. So we divide by 2. 49 divided by 2 is 24, and we keep here the remainder. So the first remainder is 0. Now we take the second number, 24 divided by 2, the result is 12 and remainder is 0. 12 divided by 2, the result is 6 and remainder is 0. 6 divided by 2 is 3, remainder is 0. 3 divided by 2 is 1 and remainder is 1. And 1 divided by 2 is 0 and the remainder is 1. So it's not real numbers division, it's integer division. This is the same as we studied in the elementary school. So the result 49 is actually equal to 110001. The calculator actually is giving us the same number. So in the calculator, if you choose the programmer, the value 49, okay, so as you see 49 is equal in binary in 100011, 100011. Okay, so this is how we do the conversion. For converting the fractional part, we don't divide by 2, but we multiply by 2. So we take, let's say we want to convert the number 0.188. To convert it to decimal, we multiply by 2, and we take not the remainder, we take the integer part. So this is 0, we take it to be the first carry. So this is the MSB, the most significant bit. Then we have 0.3, so after multiplying it we get 0.376. We take the fractional part, we multiply again by 2, 0.752, so 0. This is 0. We take the fractional part again here, 752 multiplied by 2 is 1.504. We take this one as the third number, and we take only the fractional part here. So the fractional part is multiplied by 2, 1.008. So you can continue as long as you want according to what precision you are going to use. So here using 5 precision we get 0.00110. So this is the equivalent of 0.188. 188 decimal, 0.00110 is the equivalent in binary. Speaking about the second concept in this video, which is the complement. So what is the complement? Complement actually is used to simplifying the subtraction operations and representation of negative numbers. I will speak about negative numbers next. So there are two types of complements. So the concept of complements, there are what's called according to the base. So if the base is 10, so the base is R is 10. In binary, the base is 2. So our base is 2. So we have R's complement and R minus 1 complements. So in binary, we have 1's complement and 2's complement. R is 2. 2 minus 1 is 1, and 2 is 2, of course. 2 is complement. So how to calculate the complement of a number? Of course, like I'm just giving this introduction. Later on, we will use all these concepts and you will understand why we need these concepts. So the 1's complement is just we use the inverter. We already speak about the inverters in the video speaking about the gates. So just convert each 1 to 0 and each 0 to 1. You will get the 1's complement. For 2's complement, we have two ways to make the conversion. System 1 is leave all least significant zeros and the first non-zero digit unchanged. Replace the remaining ones by zeros and zeros by 1. Same like 1's complement, but leave all least significant zeros and the first non-zero digit. So non-zero means 1. So as you see here, we all the 0 and 1, we leave them as they are, and then starting from next we change each 0 to 1 and each 1 to 0. So we leave the first one and all 0 to its right, then all change. The second way, take 1's complement of the number. So normally take the 1's complement as we do, so change every 0 to 1, 1 to 0, then add plus 1 to the LSB. So we can do like this. So change each 0 to 1, 1 to 0, and then add 1. So as you see, this result is exactly the same as this result. So this is the way how to change manually. Okay. Now using the 2's complement, actually we can this actually used by computer to represent the signed numbers. So as you know, on computer everything is 0 and 1. So how to know that this number is 5 or minus 5? Of course, in binary 5 is 101. So minus 5, how we represent it? There is no minus. Okay, so there is only 0, 1, 5 volt, 0 volt, 5 volt. So the signed binary numbers, there are several ways to represent signed binary numbers. In all cases, the MSB in signed number is the signed bit. So usually we have 8 bit or more. So the MSB, the maximum one, is the bit that is used to represent the sign. So if it's 0, that's mean positive. If it's 1, that's mean negative. The concept actually is using what's the 2's complement. So computer use a modified 2's complement for signed numbers. Positive numbers are stored in true form with 0 for the sign bit, and negative numbers are stored in complement form with a 1 for the sign bit. What does this mean? Okay, let's see this number. So if here 0, so this number is the true number. So changing this, you will find it is, let's use the calculator. So if we, as you can see, in binary, if I write 0, 1, 1, 1, 0, 1, 0, okay, so 1, 1, 1, 0, 1, 0. So this is in decimal 58. If I want to represent minus 58, I put 1 here and I take the 2's complement. Okay, so this actually is representing the negative. Let's see the calculation. So actually we take the most significant number. 1 is 1 minus 128 according to the position. So 2 power 0, 2 power 1, 2 power 2, 2 power 3, and so on, 2 power 7. So this minus, and this is the complement. So if you calculate the new number now, you will find it is minus 58. This leads us to one important concept also I want to introduce today. So as I said, it's just introduction. It's not really related to our course, but you need to know a little bit about this to continue with this course. So the numbers in computer are not lines. So you know, in integer or real numbers are lines. We start at the middle 0, then go to the right to infinity, and to the left minus infinity. In computers, no, it's not like this. It's actually circle. So it starts from 0 and finish at 0. Okay, so 0 minus 1 is FF. I will speak what is FF is the maximum actually, and FF in hexadecimal minus 1 and plus 1 is 0. Okay, so this is for the signed. So here we have what's called the overflow, and this is the non-signed, not signed. Okay, so here it's go from 0 to 255. Here it's go from 0 to 127. Plus 1 is minus 128. Okay, so I will give later on maybe some examples to understand this, but now I just want to introduce this concept. So keep in your mind, in computers, numbers are a circle, it's not a line. Okay, so that's all for this lecture. Thank you very much.